We've been experimenting with lasers on the channel as far back as 7 years ago, when I got my first low-power diode laser with an 8-inch work area. Then 5 years ago, I picked up my first CO2 laser, a fairly compact K40. Being inside an apartment made it less than ideal, but I used some 3D printed brackets to set up an exhaust for the fumes and learned a ton with that machine. Since then, we've tested out a few slightly stronger and larger, but their form factor always limited my use for them, which is largely 3D printing enclosures, large panels, and big signs. Well, June of this year, I was looking for a new laser for the shop when Omtech contacted me letting me know they were releasing a new line of machines called Pronto. After a bit of back and forth, they agreed to send their 80-watt version over for testing, and 2 months later, this beast arrived. I've had this laser for the summer months and now the very cold winter ones, as I've used it for testing and some projects I'm really excited about. In today's video, we'll be diving into the Omtech Pronto. We'll go over its specs, what setup was like, how it's performed, and I'll give you my overall thoughts based on my time with it so far. So with all that being said and without further ado, let's get right into today's video. Starting with the specs, and there is a lot to cover. The Omtech Pronto comes in a few sizes and powers ranging from 80 watts up to 150. The specific version I have and will be covering in this video is the Pronto 40, which includes an 80 watt CO2 tube. This has a work area of 24 by 35 inches and an overall footprint of 59 in width, 44 in height, and a depth of 40 inches. It's a large freestanding machine that comes with built-in casters and weighs a massive 562 pounds. Needless to say, you will not be lifting this thing, and if you have to move it from one location to another, it does require the use of a lift gate. The machine itself is largely made up of aluminum and sheet metal paneling encasing it. For motion, X and Y ride back and forth on linear guides, which is something most watching this in the 3D printing space will be familiar with. Both X and Y are driven by stepper motors and probably the beefiest belts I've ever seen that I measured at 15 millimeters. While X has its own stepper, both sides of the Y axis are driven by a single motor mounted at the back of the machine that ties them together. Each axis uses mechanical limit switches for homing to the back left. This laser has a motorized Z-axis, allowing you to work with materials up to a little over 8.5 inches tall or 220 millimeters. To access underneath the bed and the Z-axis, there is a large front panel that opens by using a key to unlock both sides of it. Down below, you'll find a pull-out tray riding on wheels that catches any cut-off pieces and debris. You can slide it out to grab the parts, or remove it completely and use the handles on it to take it over to the bin and dump out any small pieces. The Z-axis is driven by 4 ball screws, with 1 in each corner of the bed, and a large belt wrapped around a pulley on each of these screws that keeps the 4 corners in sync as it rides up and down. There's also brackets down below that can be loosened if you need to adjust the tension on that belt. As for the laser's bed, the Pronto comes with 2 options. There's your traditional honeycomb style bed, which is what I exclusively stuck with for all my testing, along with a slat bed. To access the slat bed, you need to make sure that your laser head and gantry is pushed to the back of the machine and out of the way. Then you can lift the honeycomb bed and angle it carefully as you pull it out of the machine, revealing the slats beneath. While I do really like having both options, it's pretty tight inside of the machine, and even after taking the honeycomb bed in and out a couple times just to see how easy or difficult it was, I found it to be a bit challenging to do without accidentally bumping the insides of the machine. If you're only occasionally swapping, it's probably not a big deal, but I do wish there was just a little more space inside to make it easier. On the bottom of the honeycomb tray are a couple large metal spikes that index with holes in the frame, which ensures it's properly aligned each time you go to reinstall it. There's an air assist tube ran from a connection on the outside of the machine all the way to the laser's head. This is routed nicely through a large cable chain, and there's another chain on both sides of the Y-axis for all cables. The Pronto includes a material autofocusing feature that sets the height of the bed based on the material you're using. This is done with a box and lens on both sides of the work area. While I'm not 100% certain, I believe this is using 1 or 2 infrared beams based on how it works. The cover on this laser has a large tinted viewing window and hydraulics on both sides, so there's no risk of it accidentally slamming down. This is probably fairly standard, but it makes opening up the laser feel really nice. There's also limit switches that you can feel when you open or close the lid, which automatically kill the laser if it's opened while running. Towards the right front of the machine is the controller's interface. This is using a Ruida controller, and here you can manually jog the laser, pulse it, set the origin, frame your job, autofocus, and adjust a fairly large number of machine settings. Behind it is the power button, a key for enabling the laser power, and an emergency stop button. While an e-stop is also fairly standard on a lot of these machines, I do like that it's right at the front. On the right side of the machine, you have your connectivity. It can take a USB flash drive, USB cable, and Ethernet. I've used a USB cable exclusively so far without any issues, but I know a lot of people that swear by Ethernet as being the more reliable option. Just about every section of this machine is a panel that can be opened using the included keys. This makes troubleshooting, swapping parts, or dialing in your laser's path so much easier than having to cram into some awkward spot. The large panel on the bottom right is where the majority of the electronics for Pronto is housed. Inside of that panel are 2 large fans for removing heat and keeping the electronics cool. While I've never built my own CO2 laser from scratch, so I don't have much comparison, the electronics on this thing were much cleaner than I'd expected. All wires are labeled and routed through cable raceways. As someone who's done a ton of wiring for various 3D printer builds and knows how tedious the process can be, I really appreciated how good everything looked. Moving around to the back, on the very top we have a hinged compartment that houses the laser's tube. There's covers on all the mirrors when the laser arrives, so you'll need to make sure you open this up and at least remove them before pulsing the laser. The back also includes 2 power inlets for the external exhaust fan and the air assist. So far, this has worked really well, and they turn on when a job is running, and after a set amount of time, turn off when it's completed. Under the air assist connection are a few additional connectors where you'll attach the inlet and outlet from your chiller, your air assist tube, and another cable from the chiller to the laser that lets the laser know that the chiller is running. Opening up the doors on the back of the laser is where you'll find the dedicated power supply for the laser's tube. I never had this door open while running the laser, but it looks like there's a small LED screen that will display its power draw while in use. The connection for the exhaust tube is at the very back center of the laser. This is something I'm not a big fan of, and I prefer to have it on the side of the machine if possible. The Pronto is a fairly large unit, and having a tube on the back means it really can't be flush against the wall and needs somewhere between 8 to 12 inches of clearance. Before we move on to the setup, I want to take a brief moment just to appreciate how good this laser looks. From the anodized aluminum to the paint job on the front, I really appreciate that they spent the extra time on these details. It also has an internal light to illuminate the workspace, and 2 LED strips on the front that act as status LEDs when the job is running, idle, or open. As for setup, the largest part of that process was actually getting the machine out of the very large shipping crate that it arrived in. While I didn't record this process because I was too excited and there wasn't a whole lot of space, it primarily involved me running around with a drill and removing something like 40 to 50 screws. Next was getting the laser off of its feet and onto its built-in casters. This process really just involved me on the ground with a wrench, turning a bolt on each of the legs that drops the laser down until the feet are higher than the casters and it's free to roll. The freight company that delivered the laser was awesome, and I was actually able to get them to bring the crate inside of the garage so it was on pretty flat ground. But I do have some concerns if you got it delivered on a somewhat slanted driveway that you'd really have to be cautious about dropping it onto the wheels in order to prevent it from accidentally rolling off the crate and down your driveway. The part that was a little scary was getting the laser off of its elevated platform on the crate and onto the garage floor. Since it is elevated and and it does weigh so much, you definitely don't want to just roll it off the side of the crate and have it slam onto the floor. While waiting for the laser to arrive, I watched quite a few different laser unboxing videos and saw one example where the person received their laser and actually built a small ramp for it so they could then roll it off of that platform. This seemed like the best option based on the things I had available, so I ended up just taking a few different 2x4s and some scrap plywood that I had in the garage and made a small ramp, and then I held one side of the laser and Aaron held the other, and we just sort of slowly guided it down that ramp and onto the shop floor. Once in place, the main things to do are remove the mirror covers and connect the air assist, exhaust, and chiller. The laser comes with just about everything you'll need and a handful of additional accessories, but the one thing that you'll absolutely have to get is a proper chiller. Back when I was using my K40, I was able to get away with just a 5-gallon bucket filled with distilled water, but that won't fly for this. There's also a built-in safety feature that connects the laser to the chiller with a cable so that the laser won't fire without the chiller operating. This is to prevent permanent damage to the tube caused by overheating. Omtech has two chiller options, but they're fairly similar in capacity, and the silver version that I got in seems to be the latest version. While I've used distilled water without any issues so far, even with the garage being insulated, I have concerns about potential freezing, which would damage the tube. Because of this, I placed an order for 2 bottles of Omtech's laser coolant that's good down to -30 Fahrenheit that I'll be using for the next year, with plans to hopefully get a mini split for the garage workshop. This is something you'll need to consider depending on where you live and where you'll be placing your laser. With everything connected and the chiller powered on, it's time to power on the laser. I started off by spending a bit of time going through the screen for the controller and trying to familiarize myself with its different settings. I followed this up with jogging the bed and laser just to verify that everything was working as expected. There wasn't a whole lot of mention about beam alignment, and I had seen someone say theirs was perfectly aligned already, so I ran a quick test. While the CO2 laser seemed fairly aligned, the separate red dot laser clearly needed some tweaking. After getting this thing unboxed, I was a little too excited, so I decided to just run a quick job. I then grabbed a small piece of plywood and focused the laser. The process for this is to jog the bed down below the sensor, and then to place the material in the sensor's path. I found aligning it towards the back right was easiest. Then just press the focus button on the laser and enter to have the laser jog the bed up until the top of the material triggers the sensor, letting the machine know it's in focus. The laser came with a manual focus stick as well, so I checked it and found that it was pretty close but just a little off. What I later discovered was that this wasn't an issue with the sensor, but a result of warped wood. A lot of the thin ply comes pretty warped, so the sensor is always going to trigger at the highest point. I'm still playing around with a few different ideas on how I want to secure the material so that it's as flat as possible. Omtech provided me with some rough parameters for the laser, but I've always found it best to dial in the machine and your specific materials yourself. So I ran a grid of cut tests and engraving tests to at least give me a baseline that I could work with. I then used these settings to engrave and cut out a fairly small shark. Considering this was my first run, I was really excited, and the shark now permanently lives on our fridge. Next was time to dial in the red dot laser. This was actually much easier than I expected and only took me a few minutes. While doing that, I decided to also make some slight adjustments to the mirrors for the CO2 tube to get it perfectly centered. I won't dive into the specifics of this since Omtech has a very well-written guide as well as a step-by-step video covering the process. But in summary, you loosen a nut, adjust a thumb screw a fraction of a turn, hit pulse, and repeat the process while replacing the tape each time until it's centered, then secure the nut again. Once I had this dialed in, I spent quite a bit of time testing out the laser with both engraving and cutting on acrylic and plywood, which are the main materials I plan on using this laser for. The first project I wanted to use the laser for was to cut out some custom panels for the LDO positron I was building. To do this, I took the CAD file from the project repo, imported it into Shaper 3D, and exported the panels as DXF files that I could then use for the laser. While these panels are mostly flat, there's a slight inlay for the LED cover that I wanted to see if I could replicate. It didn't turn out perfect, but by playing around with speed, power, and line interval, I got a result that I was pleased with and functional for its purpose. This was a two-colored acrylic that was white with a pastel minty blue and was a perfect fit on the printer. Next, it was time for something bigger. We've wanted a height chart for our son for well over 6 months, and I actually had gone ahead and ordered one off of Etsy at one point. When it arrived, we were really disappointed with how thin the wood was and just how warped it was, which made it nearly impossible to secure onto the wall. So I set out to make one myself. I started out using ChatGPT to generate a baseline image of a giraffe that I then traced and heavily edited the nodes on until I was happy with the design. I also added all of its spots, lines, and numbers while customizing just about everything on it. I picked up some large sheets of 1/4-inch ply and cut each of the 2 pieces out. The laser did a really good job, but around certain sections it didn't quite cut as clean through. While much less than the thin wood, it still had a slight bit of warp, which is what the cause was. For now, I updated the settings to run a little slower and with a little more power until I can get my work holding dialed in. As far as finishing, I took some sandpaper to remove a bit of the residue and then applied a thin coat of polyurethane to it. I love how this turned out and think it looks great mounted on the wall. After that, I moved on to some clear acrylic. Using this, I engraved the Modbot Army logo and cut out a new panel for the front of my Python AMS. I didn't need all of the dryer slots on the front and also wanted to give it a custom look. The other panel I cut is for the Ratrig VCore 4. I got an early unit in that was used at the Rocky Mountain Rep Rap Festival that had developed some stress marks on the front panel. I was able to find the DXF files online that I then downloaded and decided to give it a little flair, so I added the Ratrig logo to the bottom corner of it. This is a very large panel, and funny enough is the exact max size that this laser has available. Because of this, I got an error when I tried to run it, so I shaved 1 millimeter off of the width and it completed without any problems. This panel is probably the largest panel on any printer I own, so I'm stoked that I was able to cut it out with the Pronto. Lastly, I've been wanting to take the Modbot Army logo and make a sign for the studio. I had a handful of ideas on how I wanted to make it, but decided to use the same 1/4-inch ply that I used for the height chart. I took the PNG graphic that I had and broke it up into multiple layers, so I could stack them and give the sign a bit of depth, then I ran the job. Aaron gave me the idea of cutting out a stencil to help me place all of these small parts on the top layer that made things so much easier. For post-processing on these, I went with acrylic paint, which took way more coats than I had expected. The darker colors weren't an issue, but the orange, lighter green, and yellow took 3 to 5 coats before I was happy. For adhesive, since I'd painted the whole layer, I couldn't use wood glue and settled for a 2-part epoxy. I'd purchased a strip of LEDs for the back of it, but didn't realize until it was time to place them just how far apart each LED was. This meant I had to get creative with the routing. And while they don't look pretty on the back, it's completely hidden and gives a really nice glowing effect, which is what I'd hoped for. For mounting, I wanted the sign to be about 20 millimeters off the wall, so you couldn't see the LEDs and the light would diffuse a little. I ended up getting a little creative and designed a fairly simple anchor standoff that bolts into the wall, press fits an M5 nut, and then a screw goes through the sign and into the nut to hold it in place. I'm really pleased with how this turned out, and being able to combine both lasers and 3D printing into one project was awesome. So what are my thoughts on the Omtech Pronto based on my time with it so far? Overall, using this laser has been an absolute treat. The form factor is perfect for my needs, I love that it's on casters, the material sensor has worked really well, and I'm very pleased with the build quality. The 80-watt tube combined with the linear guides lets me run the machine quicker than any previous laser I've used, and maybe a small detail, but the lighting is such a nice touch. Both the internals for illuminating your work area in a dim shop, and the status LED strips on the front. But with like any printer or laser we've tested, there are always things that can be improved on. The 2 I mentioned earlier were related to the work surface and the exhaust. While I stuck with the honeycomb for all of my testing, the couple times I pulled it out to see what the process was like, I found it to be a bit of a struggle to not hit the inside of the machine as I carefully tried to angle it out of the way. Had they made the inside just a hair larger, it would have made this a much easier process. For the exhaust, while I've used lasers that have the port on the back, I really prefer it to be on the side. Due to its location, the laser has to be about a foot off of the wall to prevent any compression to the hose, which means it eats up more space and there's just a big gap behind the machine. And lastly, with this being a brand new machine, it would have been really nice if they included a USB camera. Luckily, this is something that can be added that I will be adding in the coming months, but it feels like something that should have been included. For a lot of what I did, it wasn't a big deal, but when trying to center a design on material or use up a section of partially used material, it's a much quicker process than manually framing with the red dot laser. With the price of this laser currently going for just under $5,000 and the sheer size of it, it feels like it's targeting more of the small business space. But for that price, you are getting a lot of machine. It's proven itself to be very capable, and I'm looking forward to using it in future projects. For anyone interested in getting a CO2 laser but wanting something smaller, Omtech does offer a pretty broad range of machines varying in size and power. And that has been the Omtech Pronto. After 4 months of playing around with this machine and gathering all sorts of information, it was very difficult to slice it up for the video, but I did my best to include everything I felt was important in this sort of condensed format. I hope I was able to answer the majority of the questions that you had and show you a little bit about what the machine is and what it's capable of. For anyone interested in finding out more, I'll have a link in the description over to Omtech's website. If you have any cool ideas for projects or materials you'd like to see tested, let me know in the comments. On that note, don't forget to like and subscribe for more great videos. We make a video just about every single week, so there's always fresh content coming your way. And if you do want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot, and I look forward to seeing you guys in my next video. Peace, guys!